Cloud computing is causing a transformational shift in the way we do business. It touches almost every part of the technology landscape. So why don't we start by defining cloud computing and its security challenges as a direct result of cloud customers losing control over their information assets in the cloud in an increasingly complex regulatory environment. Cloud computing is about consolidating computing resources. It's really the next stage in the Internet's evolution, providing the means through which everything from computing power to applications can be delivered as a service wherever and whenever you need. Now, we've had web services for years, right? From webmail to search engines to access to corporate resources via VPNs. So how is cloud computing similar or different to that? Well, it's similar in that we consolidate resources on the network. And with that, we're sort of going back to the mainframe world where everything was centralized. But it's different in that the consolidation is done in a much more efficient and effective fashion. The keywords in this definition by the NIST, NIST, are shared pool of resources, in that we're virtualizing anything from networks to servers to applications, but also on demand, because we're going to a subscription economy where you pay and scale as you go. And also rapidly provisioned would be a key word here. This is also known in cloud talk as elastic provisioning. But what is cloud computing really? Well, the essential characteristics we just mentioned, on demand and rapid elasticity and resource pooling, are driven by technologies such as virtualization, a key technology in any cloud infrastructure. And virtualization derives into elastic provisioning, where you can move virtual machines around, and actually virtual machines move to different physical places when the original place goes down, when the original server goes down. But the most important thing here, that's what happens under the hood. The most important thing here is looking at the resulting service models. You'll notice here that it's all about customers delegating pieces of their information technology infrastructure to service providers. And in the process, they lose control of those resources. So different acronyms here indicate how much control customers are losing. For instance, in an infrastructure as a service model, the vendor only provides the underlying infrastructure, which includes network storage, computing resources, and virtualization technology. In a platform as a service model, on the other hand, the vendor not only provides that, but also the application development platform. Now, resources can be delegated to internal organizations in the case of private clouds, or to external providers in the case of public clouds, or a combination of both in the case of hybrid clouds. So as you can see, it always goes back to the good old OSI reference model right there. In infrastructure as a service, for instance, your developers will still have a whole lot of operational work. They will get the operating system, the facilities, and all the way up to the virtualized infrastructure, but still have to perhaps manually configure several components like applications and platforms. In platform as a service, they will get up to here, and so they have fewer things to manage, more things that they lose control over. The challenge here, though, is that you're effectively delegating control to the cloud provider, and you're moving your computing and information assets to a complex multi-tenant environment. But it doesn't stop there. We need to add to that the complexity in the ecosystem of entities involved, and that's shown right here. This definition of Cloud Security Alliance is very, very fitting. You're losing control, but you're losing control to eventually multiple providers. For instance, a cloud consumer here could request cloud services from a cloud provider directly, or perhaps through a cloud broker. But still, the transport is provided by a cloud carrier, and the monitoring is done by a cloud auditor. So not only is your data in the cloud, but eventually in many places of the cloud and held by different entities. Another challenge is the complexity introduced by virtualization. Virtualization is known to provide so many benefits, right? Better server utilization, consolidation, customer segregation, and all of those things. However, it does result in a more complex environment. And that's because the trend is not only to virtualize servers and applications, but also network components like routers and switches. Also, the security infrastructure to protect them, like firewalls and IPS. So in the end, what looks like this, just a regular server, will eventually be logically this. So you have virtual routers, virtual switches, virtual servers, virtual firewalls, virtual intrusion prevention. And the challenges of managing this complexity can result in security vulnerabilities. Now, virtualization in and of itself does bring with it all the security concerns of, for instance, operating systems running as guests and vulnerabilities at the hypervisor layer, new virtualization-specific threats. Theoretically, you could have inter-virtual machine attacks and blind spots and performance concerns and operational complexity from virtual machine sprawl. And all those things add to the problem. Now, a direct byproduct of virtualization, which actually results in one of its most powerful benefits, is multi-tenancy. Cloud providers are likely to be running servers and applications for multiple customers in the same hardware, providing the illusion of segregated resources. That's what's called multi-tenancy. Now, the impact in security is clear. For instance, does the virtualization infrastructure allow for visibility of data and transactions from one virtual server to the other? Attacks and data breaches could easily spill over to other customers. Another challenge is monitoring. When allowing customers to monitor their environments, will they be able to see each other's data? So consolidation and virtualization result in great benefits, but you end up having all your eggs in the same basket. And if the basket gets stolen, then you lost all your eggs. How about mobility? If my cloud provider is protected, how can mobile users accessing cloud data remotely have an impact in security? Well, those mobile devices are by definition out of your administrative control when users travel. So they may actually be accessing the cloud from a non-corporate device where you've never installed any security software. More and more people are accessing the cloud and corporate resources from consumer devices, like their own smartphone, for instance. Very often, those devices don't comply with corporate security policies, and they actually eventually store corporate information. Also, very often, individuals have their own personal cloud services, like their cloud backup for their personal information. And at that point, smartphones become a bridge between the cloud service and uncontrolled destinations, ones where neither the cloud customer nor the cloud provider have control over. Now, all these things are augmented by the nature of the threats that affect cloud computing. The usual suspects in terms of threat vectors still apply to the cloud. So distributed denial of service will be there, as well as SQL injection and the whole laundry list of threat vectors that affect non-cloud environments. They actually become more impactful because they affect multi-tenant environments. This is what they call an expanded attack surface, because you now have multi-tenancy and virtualization in the middle of the whole thing. Now, of course, some new threat vectors are starting to catch on and become the source of incidents that we would not consider high risk in the past. They are, for instance, related to social networking and search engines, two popular tools used by employees of any organization. So you have fancy names like Kubefase and Gumblar, for instance, that use traditional access techniques to install rogue software on the operating system of connecting users in order to create what's known as botnets, or perhaps just to steal personally identifiable information from the user. Imagine if that happens on your corporate Facebook page where all of your customers are connecting, all of them get the malware. So the impact of these traditional attacks and new attacks, augmented by the fact that you have an expanded attack surface, will become a problem. Compliance is another big driver for cloud security. Even without cloud services, most businesses already have to comply with eventually multiple laws and regulations. Now, think of a cloud service where your data ends up being stored in a provider's provider network, for instance. Perhaps your cloud provider is using an infrastructure as a service cloud to expand their own storage capabilities. So data location and the regulations that apply to those locations becomes crucial. Usually, information about that location and the location of the organization's data is unavailable or not disclosed to the service subscriber or consumer. How do you know if your compliance requirements are being met then? How about information crossing borders? The governing legal, privacy, and regulatory regimes can be ambiguous. How about new compliance requirements? Do you have to comply now with the requirements of other geographies just because your data is stored over there? All those things affect electronic discovery or the ability to collect and analyze data for litigation purposes. So the ramifications of compliance go beyond the simple regulations that you have to comply locally. So there you go. Virtualization and multi-tenancy drive a complex ecosystem of cloud actors. Now your data moves across multiple virtual places, and you lose both visibility and control. And when that happens in a more stringent regulatory compliance environment, and even across geographic boundaries, then you need to think about cloud security a bit differently.